Hello everyone. Welcome to the live session for Structure, Form and Architecture, the Synergy. The course instructor for this course is Professor Subhajit Sadhu Khan from IIT Roorkee. I am Shreya. I am the course TA from NPTEL for this course. I am currently doing my PhD from IIT Roorkee. Today we will be doing the week 1 assignment 1. We will be seeing the previous year questions from the assignment 1 for the week 1. And I'll make it very clear that we don't solve this year's questions in these live sessions. We only solve the questions that have been given in previous years, and this is organized specially so that students can get a better understanding and they can see the kind of questions that are usually given and are more understanding of the course. So we will wait for 5 minutes for a few more people to join, and we will start in 5 minutes. Thank you. So it's been 5 minutes. We'll start the session now. So again, welcome everyone who has joined. Others can join meanwhile in between. So today is the live session for Structure, Form and Architecture, thus Synergy. It's an NPTEL course, and the instructor for this course is Professor Subhajit Sadhu Khan. I am Shreya Shukla, and I am the course TA for this course for NPTEL, and we will do previous year questions in these live sessions. All the live sessions are recorded and they are uploaded on YouTube. and all the presentations that I give, the PPT that I present, the details that I present, this will also be provided to you via a Google link via NPTEL only. So anything that is taught in this live session, the previous year questions and the presentation that I give, both will be available, one on YouTube and one via Google Drive link. So without any further ado, we'll start with the session. So before starting the session, I'll just quickly talk about the 4 terms that are in this course, which are the most important part of this course. And these terms are to be made very clear so that we don't have any further confusion in the course afterwards. So there are 4 important terms in the course's name itself: structure, form, architecture, and the synergy. So what is structure? Structure can have a lot of meanings, and it also has a lot of meanings, but we will be looking at the meaning of structure specifically in terms of architecture or construction, you can say. So in architecture, it refers to the system which is used to support and transmit possible loads on the building to the ground. A structure gives stability, it resists stresses and strains on the building. So a structure in architectural language is a framework or a system which is used to transmit the load on the building to the ground. What is form? In architecture, again, form also has a lot of meanings in different subjects and different disciplines, but we will be talking about what is form in architecture. So what is form in architecture? It's a 3-dimensional object or building that is perceived by a viewer in space and time. So a form is basically a 3D object, or in terms of architecture, you can say it's a building or anything that can be perceived by a viewer in a space and time. And you can see the form of a building, or you can say an object, and it is made possible to understand the form of a building or an object by the action of light and shadow. Because of the action of light and shadow, we can see the form of the building. We can form a visual perception of the building or the object in front of us, which gives it a form. What is architecture? Architecture, in very simple words, it is the art and technique of designing and building. It is the whole process. Architecture is the whole process, right from the concept to the designing to the building. The whole process is architecture. Then now, what is synergy? So synergy means the interaction or cooperation of 2 or more organizations, substances or agents to produce a combined effect greater than the sum of their separate effects. What synergy means is that if you combine 3 things and you have a sum, the synergy is an amalgamation of those 3 things which will be more than even the sum of these things together. So synergy is, in another words, you can say it's not just addition, it's an amalgamation of different organizations, different substances. In this case, these 3 different things: structure, form, and architecture. We will be talking about the synergy of these 3 things in the sense that it is not just addition to one another, it's an amalgamation where everything plays an important role and everything adds to the other thing. Moving forward, the objectives of this course is to learn the relationship between structure, form, and architecture, to make a synergy between them, to know the fundamentals of structural forms, its pros and cons, to learn the structural application through suitable case studies. And another very important part of structure, form, and architecture is the Vitruvian triad given by Vitruvius. In Latin, the words are formitas, utilitas, and venustas. Venustas meaning delight or aesthetics, utilitas meaning utility or commodity, formitas meaning firmness or strength. So venustas is aesthetic beauty, experiential enjoyment, artistry, or you can say the form. Utilitas, the functionality, adequacy, usefulness, satisfies the pragmatic requirements. And formitas, structure, it gives the structural integrity, durability, construction quality. So formitas means firmness, and it means that it should stand up robustly and remain in a good condition. Utilitas conveys utility, which means that it should be useful and functional for everybody to use it. And venustas means it should be delightful to look at and it should make people happy. So the syllabus of week 1 covered in this course is Introduction to Structure, Form, and Architecture, Relationship of Structure to Architectural Buildings, Part 1, Relationship of Structure to Architectural Buildings, Part 2, Loads on structures, synthesis of architectural and structural form. Also, if anybody has any doubts, you can write it in the comment section. I am not allowing everybody the access to their microphones. Otherwise, it creates a lot of dis. Hi, there was a temporary loss in the connection. I hope I am audible again. So I was saying that everybody can write whatever their doubts are in the comment section, and after I'm done with the session, I will answer all your doubts in the question and answer round. So I'm not allowing everybody access to microphone because it creates a lot of chaos and a lot of disturbance happens because of it, because it has happened in the past. So if anybody has any questions, you can write it in the chat box. And last is synthesis of architectural and structural form. Without any further ado, we will start with the session now, in the sense that we will start with the assignment. So there are usually 10 questions in one assignment. I have curated 15 questions from 2-3 years of questions, previous year questions. These are all previous year questions. These are not this year's questions, and we do previous year questions only in this session. We don't do the this year's question. You are supposed to see the lecture and study and then do the this year's question. So these are all previous year questions, and I have curated 50 questions for you from previous 2-3 years. So number one, name the following building designed by AR architect Zaha Hadid. So this image has been given, and they have given name of 4 buildings designed by Zaha Hadid, and you're supposed to identify which building it is. So the 4 options given are Neuralgic and Contemporary Art Museum, Contemporary Arts Center, Stazione Marittima di Salerno, Heather Relief Center. And these are how all these 4. So this is the question. Question is given with an image. This is my explanation part. This is not part of the question. So these are. This is how the 4 buildings, for all 4 of the buildings designed by Zaha Hadid look like. Neurogenic and Contemporary Art Museum, Cagliari, Italy. Stazione Marittima di Salerno, Salerno, Italy. Contemporary Art Center, Cincinnati, Ohio. Heather Ali Center, Baku, Azerbaijan. So it's very evident that the answer is Heather Ali Center, Baku, Azerbaijan. I'm adding, usually in what I have done so far in my NPTEL courses and in my style of explaining this, is I add a little detail about the buildings the answers have, so that people can remember some details about those buildings, and they can understand it better and have a better idea about it. So Heather Ali Center is located in Baku, Azerbaijan. It is a cultural center. It was designed by Zaha Hadid. The area is 1,18,000 meters square. It was completed in 2013. The center was designed to become the primary building for Azerbaijan's cultural programs, breaking from the rigid and often monumental Soviet architecture. So Azerbaijan used to be a part of Soviet Union, as in a part of Russia, and after they got their freedom or separation from Russia, and they focused heavily on their infrastructure and building their own image, and they invested heavily in their architecture. So this building is not just a cultural center in Azerbaijan, but it was designed to showcase and to actually break from the monumental Soviet architecture style, because Azerbaijan wanted to establish its own identity. So the design by Zaha Hadid, it establishes a continuous fluid relationship between its surroundings, plaza, and the building's interior. So the use of this flowy curvy architecture was majorly to connect the interior of the cultural center to the exterior, and so that there is a fluid and continuous relationship between the two, and there is no rigidity between the interior and the exterior. The interior space is dedicated to the collective celebration of contemporary and traditional Azeri culture. Elaborate formations such as undulations means ups and downs, Bifurcations, folds, and inflections modify the plaza surface into an architectural landscape that performs a multitude of functions, welcoming, embracing, and directing the visitors through different levels of the interior. The building also blurs the conventional differentiation between the architectural object and urban landscape, building envelope and urban plaza, figure and ground, interior and exterior. So that was the main idea behind the design of this center, to blur the conventional differentiation between these different things. So that's why there is so much fluidity in this, in the form of this building by Zaha Hadid. So our answer is Heather Ali Center. Moving to question number 2. The Barajas Airport Terminal in Madrid is representing visual dash in architecture, order, chaos, dynamics, or static. So if you guys have gone through the lectures, you would have come across this part that Shubhajit sir explains in the videos very clearly. But in case you have not yet, you can go to it later and you can understand it in detail. So there are, from a book called Structure as Architecture, by I'm forgetting the name of the author, he has taken up these concepts which defines the connection between the architectural concepts and structures in buildings. So there were four pairs that were explained on basis of that: order and chaos, stability and instability, static and dynamic, and grounded and floating. So based on these pairs, the question was formed that, Barajas Airport Terminal in Madrid, what does it represent? So you have to have an understanding of all these terms and you have to have go through this to be able to answer it. And another very important thing about the questions in these in this course is that sometimes the image of the building might be given to you, but many times the images of the buildings might not be given to you. So you need to be aware of the buildings and their structural form and their architectural forms to be able to answer the questions promptly. And these are mostly famous buildings that are added, not all the buildings, any random buildings would be given. Usually the buildings that have been covered in the course would only be given to you, but yeah, and these are really famous buildings by really famous and big architects. So you will have to have some kind of, you'll have to remember the form and structure of these buildings to be able to answer these questions. And for this course, for understanding better, I add the images myself. So this is how the internal part of the Barajas Airport Terminal of Madrid looks like. So it is located in Madrid, Spain, and it was started building from 1997, and it was built in 2005. The total area is 1.1 million meters square, and the cost was around 448 million euros. The main architects was Richard Rogers, Richard Sturck Harbour Partners. Co-architects were Estudio Lamela from Spain itself. Structural engineer was Anthony Hunt Associates, and the landscape architect was Das Ados, and facade engineer was Arup. So this is a sketch from the architect itself. So what happens in this building is, as you can see, it is very flowy, and it does not have rigidity. So yeah, the core building comprises of a sequence of parallel spaces separated by a linear block, and which allows the daylight to penetrate deep into the interior. And the roof is made of bamboo linear roof structure, and it is connected above by a chain of roof lights, which permits maximum flexibility in the arrangement of accommodation on each of the floors. And this enables the building to be expanded in phases. The new terminal has a metro, rail station, landside transit link to the existing terminal, as well as the transit system. Also, the idea behind this building was the use of smooth curves, the flow and transition, and it creates a sense of dynamism in the form of structure. So going back to our question, the question asked that the Barajas Airport Terminal in Madrid is representing visual dash in architecture, and the options were order, chaos, dynamics, and static. So our answer is dynamics. It does not exactly represent order, although it's quite symmetrical, because order is supposed to be something very strictly ordered, and this is because it's a flowy thing, so it cannot be ordered that way. We cannot write we can see from the building picture that it's not chaotic, because it is still arranged in a way, and it is not chaotic and not random. And you can see the dynamism very clearly in this, which has been given because of the curvy linear bamboo roof that has been added over here, and it is not static because of again the flowy nature of the roof. So here is a section I have added in which you can see how the roof actually looks like, which actually provides the dynamism of this building to it. So our answer is C, dynamics. Question number 3. Excuse me. The strength of earthquakes is measured by Likert scale, Beaufort scale, Richter scale, or Vernier scale. So probably most of us know the answer about it, that it's Richter scale. I would just quickly give a few points what is Richter scale, just for a better understanding. So the Richter scale is also called Richter magnitude scale, and Richter's magnitude scale and the Gutenberg Richter scale. It is a measure of the strength of earthquakes, and it was developed by Charles Francis Richter and presented in his 1935 paper where he called it the magnitude scale. It was revised and renamed the local magnitude scale later. It uses a formula based on the amplitude of the largest waves recorded on a specific type of seismometer and the distance between the earthquake and the seismometer. That scale was specific to California earthquakes and crust. Other scales based on wave amplitudes and total earthquake durations were developed for use in other situations, and they were designed to be consistent with Richter scale. So this is how a Richter scale looks like, and this is uh, just a visual representation of how a seismograph records the largest amplitude of seismic waves, and then it is plotted, it is graphically plotted against it, and to understand the magnitude of the earthquake. And as you can see, the scale is already given. So if it crosses the point, you can see not felt from minor to small to moderate to strong to major to great. And there are a few examples they have given here in which the scale shows how huge the magnitude of the earthquake was. For example, the earthquake in 1964 in Alaska had a scale of 9.2, which means that it was a really high scale, and it lies on the greater Richter magnitude. So our answer is Richter scale. Question number 4. The Statue of Unity is situated in London, India, New York, or Paris. And I think we know the answer to this. The Statue of Unity is located in India. So, but I would still just quickly define a few facts about Statue of Unity and also about the structural part of Statue of Unity. It is right now the world's tallest statue with a height of 182 meters. It is a statue of Indian independence activist Vallabhbhai Patel, and the construction started in October 2013 by L&T, and it took 3.5 years to complete. The total construction cost was 27 billion for this, and it was designed by the Indian sculptor Ramveer Sitar, and it was inaugurated on October 2018, which was the 143rd birth anniversary of Sardar Vallabhbhai Patel. And if you can see in this image, there is a clear comparison between the height of Statue of Unity with that of Statue of Liberty. Statue of Liberty is only 152 feet and Statue of Unity is 597 feet. And if you can see this image, you can see the difference between these two clearly, and which is just to show the comparison how huge it is right now. So this is I did not get a better image, so I have added this one. It's actually a cross section of the statue to show how the core and outer cladding is. And this is a construction image of the statue itself, in which shows very clearly that first a framework was laid out, and later the cladding or the plates were added, which were specifically carved each, and then they were all binded together. So the core of this statue is built of cement and concrete, and structural 6,500 tons of structural steel has been used, and 85,000 tons of reinforced steel has been used. The outer facade is of bronze plates, which are also quite heavy, and 1,700 tons of bronze plates and 1,800 tons of bronze cladding has been used. So if you can see this image on the right hand side, you can see there is a huge part that goes from down to below, and there are different zones divided. And you can see that how a few white lines, if you can see, those are the external structures to support the cladding, and then cladding has been fixed on those structural frames. So our answer is the Statue of Unity is situated in India. TWA Airport Terminal in New York City is inspired by the form of a kite, ant, butterfly, or a bird. So, like I explained earlier, you need to have a clear image of these buildings. These are really famous buildings, and once you go through the lectures or you read about them a little, you will remember these buildings very easily also. So, TWA Airport Terminal is located in New York City, and again, I have done the same like I am doing in the past question, that I would add some pictures about the building so that you can remember about them, and I am adding some facts or some details about the architecture or the structure of the building to give a better understanding. So, TWA Airport Terminal in New York City is inspired by the form of a kite, ant, butterfly, or a bird. So, this is how the TWA Flight Center, the Trans World Flight Center, looks like. It's an airport terminal and hotel complex at New York City's JF Kennedy International Airport. It was designed by Eero Saarinen, and it was designed in on May 28, 1962. So Saarinen used reinforced concrete to represent the metaphor for the flight. The building rests on a carefully and with great majesty, looking as if it was a giant bird ready to start flying at any time. So because it was a airport terminal building, the main concept or the main idea behind Eero Saarinen's this design was that he wanted something to represent the metaphor of flight. So he thought of a bird, and that's why he designed this terminal building. And it's a it's a cantilevered shelled kind of structure on both sides, uh, and it looks like it is as if it's a giant bird which is ready to fly at any time. So yeah, this is what the main idea or main concept behind the building is. If you can see, I have added pictures of the building from different angles. You can see from different angles all these pictures how they look like, that it's a bird with a beak in front and with its two wing flap open, and it's about to fly. So our answer is it was inspired by the form of a bird, which was also a metaphor for a flight, and which he thought was suitable for airport terminal buildings. Question number 6. Which of the following building represents visually floating in architectural concept? So like I mentioned about, there are a few architectural concepts. I mentioned it earlier. A few architectural concepts have been discussed in the NPTEL course. So now 4 examples have been given here of 4 buildings. The Heather Ali Center in Baku, Farnsworth House, Plano, Illinois, IIM Ahmedabad, Rolex Learning Center, Lausanne, Switzerland. So now you have to answer that which of these buildings visually represent visually floating in architectural concept. So to be able to answer this, first of all, you need to know how all these 4 buildings look like, and then you also have to know what visually floating in architectural concept means. So yeah, so I have added picture of both the buildings. The Heather Ali Center we just saw in the previous question, and this is how the Farnsworth House in Illinois look like. This is IIM Ahmedabad, and this is how the Rolex Learning Center in Switzerland looks like. And again, I mentioned the 4 design concepts, architectural concepts: order, chaos, stability, instability, static, dynamic, grounded, floating. So now the question specifically asks that which of these buildings talk about floating, visual floating. So all these concepts that we are talking about right now, these are all visual concepts. These are not structural concepts exactly. So when we say stability and instability, it does not mean structural stability or structural instability. It's about visual stability or visual instability, in the sense that a structure is of course standing because it is stable, but it may be designed in a certain way that it looks unstable. So same way, grounded and floating. So a structure cannot be floating in the ground because of the gravity, everything has to be on the ground. But it is designed in such a way that it looks like it's floating. So that's the idea of floating. So when we talk about grounded and floating pair, grounded means that it looks like it's on the building, it's on the ground, and floating means that it looks like it's slightly above the ground. And it is all based on the design. So a floating structure, it provides a sense of floating. It has minimal support with really narrow columns and gap between the ground level and the ground. So there is always a gap between the ground level and the ground, and it may be supported on narrow columns, which may give it a look like it's floating in air and rather than strictly sitting on the ground. It could be a heavy mass structure with a shallow vertical structure. It could be a largely cantilevered structure which can give it a look of that it's floating. So when we go back to these buildings again, you can see that the Hyder Ali Center looks like it's sitting on the ground. IIM Ahmedabad looks like it's sitting on the ground, and even the Rolex Center is somehow looking like it's sitting on the ground. It's going a little above, but it's again coming back to the ground. So the Farnsworth House in Illinois is the one, if you see clearly that picture, that it's floating. That the ground level of this building is actually above the ground itself. There is a gap between the ground level and the ground. You can see through that gap. So our answer is Farnsworth Village, and I will just quickly talk about this house. So you can see more clearly in this picture. You can see how you can see the green grass right through this. So the architect of this building is Mies van der Rohe, and this was constructed between 1945 and 51. It's located in Plano, Illinois, and it's built on a 100-acre site. There is a narrow column and the gap near the ground level, which lessens the physical and visual connection of the superstructure of the building to the foundations, and which results in a sense of floating structure. So our answer is Farnsworth House, Plano, Illinois. Moving forward to the next question. Which of the following example represents the order in architectural concept? Parthenon, Royal Ontario Museum, Bird's Nest Olympic Stadium in Beijing, China, Gas Natural Headquarters, Barcelona. So this is how the four buildings look like. Parthenon in Athens, Greece, Royal Ontario Museum, Bird's Nest Olympic Stadium in Beijing, China, Gas Natural Headquarters in Barcelona. So our question asks that which of these examples represents the order in architectural concept. So when we look at these buildings, it's very evident that Parthenon is actually representing order in this building, because it's a building with straight columns laid out in a rectangular form, and others you can see have very dynamic, very varying forms, and which have used very different ideas in their structure rather than specifically just order. So what is order? This is just a visual representation of what order looks like. So in the sense that for a building to look actually ordered, the columns have to be arranged ordered way, the facade has to be arranged in an ordered way, and which will make the building actually look visually ordered from outside. So this is the plan and elevation of Parthenon. As you can see in the plan, the columns are arranged very orderly and very properly in a rectangular form, and as you can see in the elevation also, the columns in the front are all ordered very properly, and there is no dynamism seen in this building. So our answer is Parthenon. Question number 8. Which of the following is representing simplicity in architectural quality? So there are two parts which are mentioned in the course, in the first week of the course. First was architectural concepts, and I had mentioned those concepts to you before in the previous questions. And the second part was architectural qualities, and in which one of the qualities was simplicity. So this question is about that which of the following of these building is representing simplicity in architectural quality. Uh, just a second. So the options are Harbin Opera House, China; Villa Savoy, Paris, France; Eiffel Tower, Paris; Dong Dongmedium Design Plaza, Seoul. So this is how the four buildings look like: the Harbin Opera House, China; Villa Savoy in Paris, France; Eiffel Tower in Paris, France; and Dongdaemun Design Plaza, Seoul. So as you can see very clearly, that all these four buildings, you can see very clearly that the Opera House has a very dynamic structure with curvilinear structure and uh, very very much like the style of Zaha Hadid. Eiffel Tower also is a very complicated structural building, and or you can say a monument, you can say it. And this plaza is also very dynamic, using curvilinear forms over here. So the architectural concepts that have been mentioned in the NPTEL lecture are simplicity and complexity, open and closed, lightweighted and heavy, soft and hard, elegant and rough. What simplicity means in these architectural qualities was that simple regular elevation in which both sides are connected. So simplicity means in architectural qualities that it has a very simple and regular elevation, and the both sides of the building are connected to each other. So when we look at going back to this again, pictures again, you can see that Opera House has a very different flowy kind of feature, very continuous flowy kind of feature. Same with the Dongdaemun Plaza. It has a very dynamic and curvilinear feature. While Eiffel Tower, it's again not simplistic. It has a curve and it is a very typical structural building built many years ago. So coming back to the Villa Savoy. Villa Savoy, as you can see, it looks like a very simplistic building, which is very with a very plain facade, which is one part that follows the idea of whole simplicity. And the second part was that both the sides of the building are connected, and like you see in this image of Villa Savoy that I've added you can see that how the both elevations or both the sides of the building are connected and how simple it is. Compared to all the other three buildings, it is the most simplistic out of them. So, talking about Villa Savoy, it was designed by Swiss-French architect Le Corbusier. I'm sure we all are familiar with his work in India as well. It was built between 1928 and 1931 using reinforced concrete. It is an example of Le Corbusier's 5 points for new construction: pilotis, roof garden, open floor plan, long windows, and open facades. Le Corbusier started this whole thing in one of the eras where he talked about the 5 points of new construction, and he said that these 5 things make a modernist or international style of building. First was pilotis, use of pillars or use of columns, use of thin column. Second was use of roof garden. Third was use of an open floor plan. Fourth was use of long windows, which he also called ribbon windows, and the use of open facades, which means if you look at this building, the ground floor, the facade is completely open. Only the first floor of the facade is closed. The ground floor is completely open. It has a very open facade. This building, Villa Savoy, is also a renowned example of the international style. So our answer is Villa Savoy, Paris, France. Question number 9. Which of the following is representing visually closed form in architectural concepts? So the four buildings are again given here: Frankfurt International Airport, Swarnabhumi International Airport, Bangkok, Louvre Museum, Paris, Bihar Museum, Patna. So going back to the different concepts mentioned, so one was simplicity and complexity, another pair was open and closed, third was lightweight and heavy, and fourth was soft and hard, and elegant and rough. So now we will be talking about open and closed in for this question. So this question asks that which of these buildings represent visually closed in an architectural concept. So again, to be able to answer this concept, you have to understand the idea of visually closed, and you have to remember how these four buildings look like, what's their form, what's their structure. So these are the four buildings mentioned: Frankfurt International Airport Terminal, Louvre Museum Paris, Swarnabhumi International Airport Bangkok, and Bihar Museum Patna. So as you can see very evidently that the airport terminals, both the airport terminals and the Louvre museums, they use it's a glass facade which permits a lot of light. Although it's all these three buildings, they are closed facades, but because it's a space frame structure and they are using glass facade which is allowing the light inside and allowing a visual connection from the outside, you can actually directly see from inside to outside or from outside to inside. There is no break in visual connection, although even if there is a layer, there is no break, which makes it not exactly completely opaque or closed. So because there is no opacity, there is opacity in this, there is a layer, there is a transparency, there is opacity because of the glass curtain walls or the space frame structures. These do not feel like they are completely enclosed spaces. They do not give the perception of closedness. While when we look at Bihar Museum, it's a solid wall, curved or straight, which have been used in the Bihar Museum. When you will be inside this building, you can see that it's a closed space rather than giving the vibe of openness or connecting you visually to the outside. So visually closed form means a sense of closed form can be done via closed plans. It can be done via closed plans, high walls, and it is opposite to the sense of visual openness. So again, going back to this image of Bihar Museum, you can see that it looks like that it's a closed plan. It has high walls with some penetrations and not exactly transparent or with low opacity as compared to the other three buildings mentioned. As you can see very clearly in the Louvre Museum Paris, you can actually, this is a pyramidical shaped like building with space frame and glass frame. And you can see that you can even in this image you can see that you can see through this museum part even through two faces of the pyramid. So that is the level of transparency or the openness achieved in this building. So of course the Bihar Museum is the answer, and I will quickly just talk about a few things about this Bihar Museum. It's located in Patna, Bihar. The architects of this building are Maki and Associates, Opolis, and it is a museum, of course, and the area is 25,000 meters square, and it was built in 2018. As you can see, this whole building, these are few of the images of the building or few of parts of the images. You can see that it's a closed form. You can see all the walls which are giving a very closed form in this. And thus our answer is Bihar Museum, Patna. Question number 10. Mention the examples below representing visually lightweight in architectural qualities. So visually lightweight in architectural qualities, it means it feels light visually in an interior form. It has column-free spaces and it is opposite of visual heaviness. So visual lightweight in architectural qualities means that it has to feel light. It should not feel heavy to look at. For example, when there is a huge concrete wall in front of you, you can see the heaviness in that building. And instead, when you see a glass facade or a glass wall, you see lightweightness or you feel light and looking at that. So visual lightness is achieved by achieving the perception of lightness and also by providing column-free spaces. For example, if there are a lot of columns in interior spaces, you would feel that it's very stuffed with things and you would find it very rigid. while if there are column free spaces, you will feel like that the entire structure is very lightweight. So for example, the airports and the museums use this concept a lot. They don't add a lot of columns in their spaces. So the museums or the airports, specifically for circulation, they avoid adding huge columns so that the circulation is easier, while in museums, openness is more important so that the artwork can be focused on more than the building dominates. Going back to the picture again, these are four buildings. So if you see, if you observe these pictures, these pictures are given as a part of the question itself. So if you can see this, you can see that very clearly. You can observe. So when you see the first image, you can see that it's surely does not feel lightweight. It looks heavy because of the use of concrete and the facade, the way it has been emerged. It has been done. Second is a picture from a stadium, and if, as you can see, it is giving a very open vibe, and because there are no columns supporting the shell structure above the stadium, it also gives a very lightweight feeling. And then when we look at the third structure, again, because of the use of the transparent material of glass, which makes it which makes visual connection easier, you can see that it does not feel really heavy. It feels light because there is a lightness associated with glass, and there is a lightness associated with being able to connect with the other part of the building. And then when we look at the fourth building again, you can see it's a huge block of concrete which gives a very heavy feeling. So by analyzing these pictures, we can surely see that the answer would be C, 2 and 3. So our answer is C, 2 and 3. Question number 11. The point on under the Earth's surface where the earthquake originates is called epicenter, hypocenter, fault center, or ground zero. So I would quickly go through the definition of all these 4 points. So what is epicenter? Epicenter is the point on the Earth's surface vertically above the focus of an earthquake. So inside the ground, earthquake occurs at one point, and at that point, that point projected on the surface of the Earth, right above it, that is when it is projected on the Earth, that point is called epicenter. And when we map earthquakes, we map earthquakes from the epicenter. Hypocenter, in seismology is the study of earthquakes. Seismology, a hypocenter or a hypocenter is the point of origin of an earthquake. It is a synonym. Is the focus of an earthquake. The synonym of hypocenter is focus of the earthquake. Fault center. A fault is a fracture or zone of fractures between two blocks of rocks. Faults allow the blocks to move relative to each other. The center of the fault is the most deformed and is where most of the offset or slip between the surrounding rocks occur. So fault line or the fault center is a zone of fracture between two lines. If you see in the image that I have added here, so we have a hypocenter focus, and when that point is projected on the surface of the earth, that point is the epicenter, and we see a crack because of the earthquake going from the center of hypocenter to the surface, and that crack between two rocks is the fault line. And then ground zero. The term ground zero and surface zero is used in relation to earthquakes, epidemics, and other disasters to mark the point of the most severe damage or destruction. So the ground zero is the point where most destruction occurs. It can be near the epicenter, it will be near the epicenter most probably, but due to other factors it may be near other points. So ground zero is the place. It is a term used in, you can say, disaster management, where any kind of epidemic or earthquake or disaster, the point where most damage or destruction has occurred is the ground zero. So our answer is the point on under the Earth's surface. It says clearly under the Earth's surface, not on Earth's surface. The point under the Earth's surface where the earthquake originates, it is called the hypocenter. So you need to remember this distinction between epicenter and hypocenter clearly. Question number 12. Excuse me. Hammering a nail onto a wall of a building is resulting dash load on the structure. So when you hammer a nail on a wall of a building, what is that load called? The answers given are resonance, dead load, impact load, or settlement load. So I'll quickly go through the definitions of all these four kinds of loads and then we will answer our question. So what is resonance load? Um, Resonance is a phenomena in which an external force or a vibrating system forces another system around it to vibrate with greater amplitude at a specified frequency of operation. So what happens in resonance is that there is an object and it is creating vibrations. Okay, so the vibrations that this object is creating might affect the object near it and cause it to vibrate too because their frequencies are matching. So this is what resonance load is. So second, dead load. Dead load on a structure is the result of the weight of the permanent components such as beams, floor slabs, columns and walls. Dead loads are also called permanent loads and these are the loads that will definitely be there when you are constructing a building. So the weight of the beams, columns and even your walls and any fixed thing that has to be there is all dead load, and it is also called permanent load because this is not temporary. These load would be there until unless something is demolished or broken up. Impact load is defined as the force provided by a sudden load on a structural part instead of a constant and sustained force applied over a long period. So what happens in impact load is that it is a sudden load. So for example, you have a structure, you have a building, so and you have placed your furniture on it. Okay, so there is a continuous load coming from that furniture on your floor, which is then getting distributed to the beams and then to columns, then to the foundation. What happens in impact load is that there is a sudden load that has been impacted on. For example, if I uh, drop something on the floor, that's an impact load because that load, imagine I have something heavy and I dropped it on the floor, that would create a sudden load on the floor. For example, a car crashing. So if a car crashes in a building or a tree, the tree or the building will face a sudden load or a sudden impact load. Impact load is a type of dynamic load, which means that it changes with time. It is not consistent, it is not continuous, it is sudden and it can change with time also, in the sense that this load only happens when the impact or the connection is happening between two things and it will not be there all the time. For example, dead load is always there, it's a continuous load always coming from permanent components. Fourth is settlement load. When one part of the building settles more than the other parts, this type of load occurs. So what happens is when a foundation of a building is laid out, usually what happens is if there is an earthquake or there is undulation in ground or the soils or the foundation has not been laid out properly or the soils are of different densities, one part of the building settles more. So for example, this is for example one whole building. Okay, my both hands are constituting the surface of one whole building, and because of excuse me, and because of the different factors that I've just mentioned, one part of the building settles down more than the other part. This is called settlement load. So our answer is that hammering a nail onto a wall. So because we are hammering a nail onto a wall, we are creating a pressure on the wall at that point, which is creating a load on the wall at that point. So it is definitely not resonance, it is not a dead load, it is not a settlement load, it is an impact load. It is an example of impact load. Question number 13. Just three more questions left. After that, I will start the question answer round. If anybody has any doubt, you can write it in the comment section. I will try to answer it as per my capability. In case I will not be able to answer your question at this moment, or I would not be sure of any of the questions you ask me and I would not be sure of the answer, I would definitely go back, read about it, discuss it with the professor, and then come back with an answer in the next session. So be assured your question would be answered for sure. If not in this session, then maybe in the next session. But any doubts, please just put it in the chat box so that I can answer it later. Question number 13. Paul Klee Museum is an example of arch structure, membrane structure, shell structure, folded plate structure. So again, to answer this question, we should be I'm sorry. Just a second. Yeah. To answer this question, again, we should be knowing how the Paul Klee Museum looks like and what these different kinds of structures look like: arch structure, membrane structures, shell structures, and folded plate structures. So I'll start with Paul Klee Museum. So it is called Paul Klee Museum because it is dedicated to the artist Paul Klee. It is located in Bern, Switzerland. It was designed by the Italian architect Renzo Piano, and it is characterized by the structure of corrugated steel deck. So you have seen corrugated sheets. So it is the idea, the concept of this structure is to show corrugated steel deck. So which is why the shape is like a curvy zigzag. So now I'll quickly talk about the four types of structures that have been mentioned in the question. So what is an arch structure? An arch is a vertical curved structure. It's a vertical curved structure that spans an elevated space and may or may not support the weight above it. It takes various shapes such as semicircular, parabolic, or pointed, but it usually have in common a single convex curvature. So arches can take different shapes, but they usually have a single convex curvature. Shell structure. A shell is a type of structural element which is characterized by its geometry, being a three-dimensional solid whose thickness is very small when compared to other dimensions. So basically what happens in shell structure is that it can take any shape, it can be made in any geometry. But what really characterizes a shell structure is that it's the 3D solid. And for example, a shell structure can be a curved. Let's imagine a dome. It can be a curved or shell or a dome. Let's imagine that. So what really defines a shell structure is that it's a 3D solid, but it has a really small thickness. So it's like rather like a sheet, a thin sheet, you can say. Very thin concrete. Usually shell structures are made out of concrete. So very thin concrete shell. It could be in any geometry. You can have it in different shapes, different curves, different linear geometries. But the main characteristic is that it's a 3D solid with a very small thickness. A curved plate structure shaped to transmit applied forces by compressive, tensile, and shear stresses, and it acts in the plane of the surface. They are usually constructed of concrete reinforced with steel mesh. Membrane structure. It's a structure with a thin flexible surface which is called a membrane that carries loads primarily through tensile stresses. There are two main types of membrane structures: tense structures and pneumatic structures. So what happens in membrane structure is that they use tension or the tensile stress to carry the load, and usually what happens in membrane structure is that the load is carried by the tension in the fabric. So membrane structures are usually tent structures in which there is one post, or you can say mast, and then there is a fabric coming out of that mast which is tensioned, and then that structure takes the load of the surface. Folded plate structure. A folded plate structure is a set of flat plates that are inclined in different directions and joined along their edges at the top. This type of structure is beneficial because it's capable of carrying loads without requiring the use of additional support beam. So what happens in folded plate structures for that different plates uh, are joined together, and they can be joined in different angles, different shapes. It could be a very symmetric folded plate structure, it could be a very dynamic folded plate structure. So you imagine different shapes or different polygons of concrete joined at inclined angles. That's how a folded plate structure would look like. So going back to our question, that Paul Klee Museum is an example of which of one of these following structures? An arch structure, a membrane structure, a shell structure, or a folded plate structure? So our answer is arch structure. Question number 14. MIT Kresge Auditorium is an appropriate example of shell structure, fabric structure, catenaries, folded plate structure. So again, to be able to answer it, we have to look at what this Kresge Auditorium, MIT Kresge Auditorium looks like, and we need to know what are these different types of structures, and then we will be able to answer it. So moving forward, Kresge Auditorium, it's a type of public space and auditorium. It's located in MIT campus, Massachusetts Institute of Technology, Cambridge, USA. The architect is again Eero Saarinen. You can see this very typical style of Eero Saarinen where he uses these shapes, these curved shapes. It was built in the year 1955. Kresge Auditorium was an experiment in architectural form and construction which befitted MIT's focus on technology and innovation. It was one of USA's first large-scale thin shell concrete buildings. This elegant reinforced concrete dome comprises 1/8 of the surface of a sphere. So if you can imagine a surface of a sphere and you divide it in half, you have semi-sphere, hemisphere. You divide it in another half, you have this part, and you divide it in another half. That one part, that 1/8 part is what the shape of this shell is. And it is primarily supported by 3 pendentives. The truncated dome encloses a triangular space approximately 0.5 acre in high area and a height of 50 feet. With the primary structural roof varying between only 3 and 7 inches thick, the span is 113 feet. And I have added a few detail over here about the cladding because it's a shell structure, right? So I wanted to add this detail about the shell structures, like the cladding over it. So they created this whole structure frame, and then they put a cladding on the roof. So it was an experimental project. They were experimenting at that time as it was built in 1955. So they were also not very sure with a lot of things. So this project required a lot of trials and errors at that point. So the main idea was that the 3 ends or the 3 pendentives that are being formed in here, that those 3 pendentives would only be the main support. But because the load was more than it was anticipated, other structural columns and addition of other structural vertical columns have to be added. So roof cladding was a challenge in here. Firstly, marble tiles and lead coated copper was thought of to be used, but it could not be done because it was not cost effective. And then a system of limestone chips dipped in a liquid acrylic polymer binder was selected to coat the shell, resulting in smooth white casing. But a lot of deterioration happened to it, and then the roof failure happened. Then square lead sheets were added. Water filtration through the lead cladding precipitated several deterioration, and the concrete and reinforcement of edge beams near edge main support had to be replaced. And then finally they had to add copper roofing was put in place, and the copper roofing still remains to this day, the copper roofing that has been added. So there was a shell, a concrete shell, and it was still cladded over it to protect it from other things and to give a better look. So as you can see in this image clearly, you can see the brown of copper still visible in it. So our answer is shell structure. Uh, Last question of the day. Which among the following visual and relational properties are encompassed by the shape of an object? So the question is asking that an object, it has shape, it has a size. An object has a lot of properties. So when we think about the shape of an object, what are the different properties that are associated with shape of an object? So the options are size, visual inertia, texture, and material. So size, of course, is related with the shape, very evident. Visual inertia, so what we mean by visual inertia is, visual inertia means the visual stability of the form. So again, for example, if you see a cone standing on its tip, it would not look like it's stable, while if you see a cube standing, you will feel that it's more stable. So that is what visual inertia is, that even if it's stable, it's still the stability of a form, the degree of stability of a form is given by that. So visual inertia. Then texture. uh, Texture can also be considered as a part of the shape. And then material. So material does not constitute the visual and relational properties. So here we are not only we are talking about the visual properties. So if a shape or the form of an object, it has a texture, then it becomes a visual property of that shape. For example, if I keep a plastic ball and if I keep a concrete ball, you can definitely see the texture on both these spheres. Even if the shape is sphere of both these balls, it's quite evident that texture is a property of that form or of that shape. So shape encompasses various visual and relational properties: size, color, texture, position, orientation, and visual inertia. So our answer would be C, P, Q, and R. So this is it from me. I have done 15 questions based on previous year questions of 2-3 years. I have combined questions from 2-3 assignments. So in every assignment you get 10 questions to submit, and I have done 15 just as a sample for it. Yeah, and these are all previous year questions. I will not be doing it as we are not supposed to do this year's question in these sessions. So it is, I will make it very clear that these are all previous year questions. So if anybody has any doubts, you can ask me, you can write it in the chat box. I will try to answer it as per my capacity and knowledge. In case I will not be able to answer your question, I would learn about it and I would do it in the next session. Yeah, if anybody has any kind of questions, please write it in the chat box. Yeah, yeah, Anmol. Every shape has a material also, but here we are talking about the visual properties. So material is not a visual property; it's rather a structural property, you can say. For example, I gave the example of two spheres, right? So the material that is there, that material defines the weight of that these two balls. For example, one is concrete and one is plastic. So the structure would be defined by the material more than the visual quality. But also material is but somewhere associated with color and texture, but because they have because the NPTEL lecture bifurcates these properties from material, the color and texture, so color and texture become more prominent as visual properties, but material does not become prominent as a visual property if we remove the texture and color part from it. If the factors that have been explained didn't say color or texture, so we could have considered material to be one of the visual properties also, because we could have considered texture and color to be a part of it. But because color and texture are being explained as distinctive factors, then material does not remain significant, because then the material falls in the category of structure more than the visual aspect. It's concrete only that has been used in Hyder Ali Center, and I think it would be given some kind of coating to protect it from the deterioration. Because the shapes that Zaha Hadid uses, those are usually her buildings are usually made out of parametric. These parametric forms that she uses in her buildings are usually made out of concrete. So yeah. So yeah, I just checked about it. So the structure is made out of concrete RCC, uh, based on steel frame structure, and the cladding, like I was saying, that they might be using some kind of coating, so they have used a cladding of GFRC, which is glass fiber reinforced concrete. So RCC has been used for the structure, and then they have a coating of GRC over it. So GRFC panels have been used on it. Apurva. Yeah, so resonance effect is basically what happens is that everything gives a frequency or creates vibrations. So resonance is an effect that is observed in both oscillation of wind and also because of earthquakes, because these both things create vibrations. So there have been cases in when the with the frequency the wind is flowing at, and there is, for example, a bridge which has a natural frequency of its own. So if by chance the wind and the frequency it's creating on the bridge matches the natural frequency of the bridge, so the bridge starts oscillating more, because that the frequency that the wind is giving the bridge is making it oscillate more, and because of which in certain cases, if that has not been taken care of structurally, the bridges tend to break. So, to tackle the resonance because of wind, usually in a lot of buildings you will see they provide some kind of dampers like bell-like structures or huge balls or like spheres. They introduce it at the top of a lot of skyscrapers and buildings because wind load is really high for skyscrapers because they are very tall. So what happens is that these objects which can oscillate, which are given at the top of the buildings, they oscillate and they take away the resonance load that the wind is bringing to the building. So if this resonance load that can come from the wind is not tackled, it will make the building sway along with it, which can cause the building to fall down or damage. And I'm forgetting the case of it, but it happened a few decades back that one of the bridges, the moment it was inaugurated, it was built, the wind resonated with the natural frequency of the bridge itself, and the whole bridge collapsed because of it. I think sir has also mentioned that example in his videos. I'll just check out once and I'll tell you the name of that bridge once and you can read about that case more. So basically resonance is that one object is vibrating and it's causing that impact on the other object, and the other object also comes in the motion because of the vibrations of the other object. One of the really oldest examples of tackling resonance effect can be seen in churches, where they installed huge bells in the churches on top of the churches. So those were for religious significance, but also for structural significance. They helped in resonance, in tackling the resonance. Yeah, it can also create a vibration, but what happens in, I'm just giving an example of wind and bridge or wind and skyscraper. So it is also, of course, any kind of load is creating a vibration or it's creating that. But what happens in the phenomena of resonance is that for every object, all of us, all the objects have a natural frequency. So when a building is constructed, it also has a natural frequency, which is the amount of sway it can take in that amount of time. So when that natural frequency of the building matches with the frequency that is being exerted on the building from an external force, then the phenomena of resonance occurs, which makes the building move much more than it should, which causes the instability. So any kind of load or any kind of external force will cause some kind of vibrations, you can say that, but it has to, that the vibrations caused by that load, when it matches the natural frequency of the building, then it causes it to destabilize because it starts swaying more. So in case of bridges, it's usually wind that causes the vibrations more, because wind has a really strong force and really strong load. So if the flow of wind matches the if the frequency that the wind is providing on the bridge, it matches the natural frequency of the bridge collapses because it starts swaying more. Same with the case of buildings or skyscrapers. That if I'm just giving an example of wind because that is a very known example, and it is used to minimize, mostly the resonance effect is minimized in the cases of wind and earthquake, because these two load create the most disturbance, or you can say they create a vibrancy or vibration, frequency or vibration, which usually matches with the frequency of the building. So usually these two loads are counted for. So I'm just giving an example with wind. So of course any kind of load would create some kind of load or frequency or vibration in it, but it's not that impactful. Resonance occurs when it really becomes impactful, or when it really matches with the natural frequency. So a force is actually being put on a building in a lot of forms. Impact load could be, uh, maybe, I am not really sure about it because I am not an expert on structures. But the whole point of resonance is that whatever the external load is happening on the building or the structure, the natural frequency of the structure is matched with the load of the frequency that is happening. The phenomena that happens in resonance is that, for example, this is a building, and in its natural frequency it's just moving this much. For example, I'm just doing it for exaggeration. But once a load is being put on this building, and the load or the frequency matches with the natural frequency of this building, it sways more, which is what causes the destability and the building collapses. I'm just giving an example of wind because that's what I'm more familiar with. Um, Resonance is the main reason that the structural engineers try to create buildings with structures which have different frequencies so that they can avoid this phenomenon. Usually it is done for earthquake and wind, and but I think because they provide a huge load on the building compared to other forces, I think, because there are many kinds of load. Impact load is just one kind of dynamic load on the building. I'll be staying in the meeting for. If anybody has any questions, you can write it. I'll be staying in the meeting for 15, 20 minutes more. So this will be the format of the live sessions, that I do questions. I solve the previous year questions, and then we have a specific time dedicated to the question answer round. where anybody who has any doubts, the questions will be answered. I usually try to solve the previous year questions for 1.5 hour and dedicate half an hour to question answer round. But somehow, even after adding 15 questions, I finished it quite early. So we have some time today. So if anybody has any questions at all, you can ask me. And if you don't have any questions, that's also absolutely fine. These all this is a recorded session, and the recording will be available on YouTube after the session, and the links will be provided to you by NPTEL itself, and the PPT that I have presented today will also be provided to you by NPTEL. Both those things will be provided. And also, whatever is the course content covered in the course, NPTEL course, that is the course content for your exams and assignments. Whatever extra information I give in these live sessions is only for knowledge and for developing a better understanding. Anything the extra that I'm adding in these presentations is not going to come in your exam or your assignments. Is not will not be a part of your assignment or will not come in your exam. So don't think that you will have to remember all the details that I have mentioned about the different buildings that I have mentioned, that you will have to remember all those details. You just have to study the course content that has been provided in the NPTEL course. You can go through the presentations, you can go through the lectures, you can go through the transcripts. So whatever detail has been given in the NPTEL videos, that is the extent of your course for the exam. Anything extra that I am showing in these presentations is only for building your knowledge. It will not be covered in the exam. So don't worry about that, that if I'm providing too many dates or details or height and width of buildings, that's just for knowledge. That's just to provide different facts about different buildings so that you can visualize them better, you can learn about them better. Um, I think it would be easier and better if you guys would once go through the lectures or the PPTs before this session, because that will actually help you write down the queries that you need to ask, and we can have a better interactive session where you can ask me your doubts. So I'm not saying that do a proper work or reading and everything, but just go through the presentation once. You can go through the PPTs from the NPTEL website. Just go through those presentations once, and if you have any doubt and if you don't understand any terms, if you would like me to explain any specific term or about any specific topic, just let me know so that I can specifically do that for you guys. This entire live session for the NPTEL TA is being done to make things easy for the people enrolling for the course. So I am glad to be of any assistance. So if you would be able to go through the presentations before the session, you can ask your doubts better. That's the only reason I'm asking. That just try to go through the presentation ones. That's all. I'm going through the lectures might take some time, but you can do that later. Whenever you have time, you can of course go through those lectures as per your convenience, but just go through the PPT so that you can see what all topics will be covered, and if you have any specific questions related to any topic, and if you would like me to focus specifically on any topic, so I would do that. If anybody has any questions, please let me know. We'll stay in the call. I'll stay in the call for 10 minutes more. If anybody has any questions, you can please write it in the chat box. From next time onwards, I will try to inculcate more questions if I will be able to, or I will try to make the explanations bigger. And it would really help if you guys can just go through the PPT before joining the session, because then you will actually have some doubts which I can clear. You can also come and tell me in the next session. For example, if you go through the presentations, you can tell me that please can you just talk about this topic a little. So I will also read about that topic more and prepare on it, and I would also talk about it in the next session. You're welcome. Reshmi, do you have any questions? Okay, thank you. If you don't have any more questions, then we can log the meeting off. Okay. Thank you so much for joining. I hope it was helpful.